Welcome back again in part third of scanning electron microscope. If you will see, the electrons which are emitted from specimen surface are analyzed by hemispherical sector analyzer HAS on the basis of energy differentiation. As voltage applied to HSA, only the electrons which have the energy corresponding to the voltage will able to pass through the HSA, and those electrons will be detected safely. The scanning electron microscope has different type of emitted electrons. When incident electron beam that excite the sample surface or electrons strike with the atoms which are present on the surface of sample, they different type of excitation takes place and different type of electrons they comes out from sample surface. So to detect all those type of electrons, different type of detectors are required, in which detectors are available for bright field, dark field, as well as segmented detectors for mid field to high angle annular dark field. And the most important detectors are able to detect the scattered electrons and back scattered electrons, in which the concept of manufacturing these detectors is on the basis of 4 fan shape, that is called as the MF shape BSE detectors. These detectors are manufactured the concept of grid, in which one wire to another wire difference that remains 1990 micron, and the thickness of one grid wire that remains around 10 micron. But nowadays these detectors has been modified by multi-annular detector, which is called MA detector in short. This is another very important concept because another kind of excitement or another kind of emission which comes in the form of Auger electrons. How these Auger electrons comes out? Suppose a atom which is present, which is the part of sample, when the electrons of electron beam that strike on a particular atom, and then the electrons strike on the electrons which are the part of that atom in different cells. So suppose a electron which is present in K cell, that is the closest cell with nucleus, the excited electrons of electron beam will replace that electron and that will go out from the atom. So in this way, what will happen? The electron which is present in L cell, that will try to replace immediately the K cell electron, and this phenomena will be a exothermic reaction. In this way, the energy will come out, and the in this way, when the electron will go out from the atom, the X-ray may generate. And the situation is that when the electron will strike the electrons of electron beam will strike the electron which is present in the electron cell of a atom. The electron of L cell that may go out from the atom. So the third situation, that is called the KLL situation, and the transition of electron will take place, and these transition electron will called as the Auger electron, and this transition is called Auger transition. And this phenomena was first observed and detected by Pierre Victor Auger, and on the name of this scientist, these electrons are called as Auger electrons. So if you will see the fixation and preparation of biomaterial as a sample, you will find various type of organisms, organs, tissues, cells, biomolecules. They are used for detection by means of SEM. So these biomaterials are cross-linked by means of cross-linker, and then they are coated by means of heavy metal salt. So in this way, the fixation of biomaterials take place by glutaraldehyde, which is a dialdehyde, and then sample fixation takes place by immersing the whole sample in glutaraldehyde. So glutaraldehyde basically react with N terminus of amino acid which are present on adjacent proteins of that particular sample. Glutaraldehyde react with N terminus of amino acid, and in this way it eject 2 molecules of water. So cross-linking of peptide chain stop all movement of protein components which are present in the cell of that particular tissue. So in this way, the fixation, or you can say dimensional stability of that biomaterial or biomolecule that comes in picture, and materials become suitable for scanning under SEM. Another technique, dehydration or air drying technique, in which the liquid content of sample replaced by ethanol or acetone before drying. So typical solvent which are used for dehydration purpose, that is the tetramethylsilane, that basically may shrink the biostructure of that biomaterial. That's why the solvent for air drying technique, solvent air drying technique is basically quick technique, and this technology restricts the resolution up to micron level, and some hydrogen cell collapse at the level of 1 to 10 nanometer range, and acetone or ethanol is used as a at concentration of 30, 50, 70, 80, 90 and 100 for dehydration. After dehydration, then the biosamples are washed with 100% solvent. Freeze drying. This is another way to prepare biosamples for SEM. Biosamples are treated with sucrose and dimethyl sulfoxide to reduce the possibility of ice crystal formation. For that point of view, cryo-freezed samples are treated with cryogen liquid like Freon 22. Other than Freon 22, there are some other cryogen liquids are also available. There is a huge list of those liquids. For that point of view, these cryogen liquid treated samples are kept under vacuum of equivalent to 10 to the power minus 3 torr, and temperature is kept 35 to 85 degrees centigrade. Critical point drying, CPD, that is a very important technique in which the samples are treated with transitional fluid like CO2, and the temperature is kept 31.1 degree centigrade and thus under CO2 medium, and zero surface tension at pressure under this situation is kept. This treatment basically keeps the stability in shape and diameter even at 100 nanometer scale. So in this way, this technique is very important to preserve the original shape of biomaterials for SEM scanning. This technology restricts the resolution up to micron level. So how this CPD technology works? So this is the typical protocol of this CPD. In a typical protocol, a cleaned sample surface of biomaterial is treated with 100% ethanol. Then it is a solution of 1:2, in which one ratio is HMDS and 2 is ethanol. A sample is treated for 20 minutes. After that, 2:1. 2 part HMDS, 1 part ethanol, sample is treated for 20 minutes. Then 100% HMDS is used for a treatment of biosample for 20 minutes, and this process repeats 2 to 3 times as per the requirement of sample and as per the nature of the sample. After that, samples are immersed in HMDS solution and covered loosely in a fume hood for 12 hours, because HMDS is a very toxic material in nature, so that's must handle with proper care. After that, samples are coated under a sputter coating machine, which works on the principle of chemical vapor deposition. Metal coating, under that technology, under that process, biomaterials and non-conductive materials are coated by means of low molecular weight compound. Under that, these materials emit low back scattered electrons and scattered electrons, which are absorb maximum electrons, and then temperature goes high. So biomaterials clean sample surfaces fine coated by gold, silver, palladium, platinum by means of sputter coating technique under argon atmosphere. and these coated specimens are mounted on sample stud with the help of carbon conductive tape. And this is environmental SEM concept. Uncoated biological sample and industrial samples are scanned by ESEM. ESEM doesn't need any extraordinary sample preparation. ESEM highly support the scanning of biological sample which cannot remain stable under high vacuum condition. The major demerit of this technique is electron beam spread in the high pressure environmental chamber and excites the fluorescent X-rays from the entire specimen surface in place of area under the electron beam, which is remain possible in case of conventional SEM. An extra detector polycapillary unit is used to detect the fluorescent X-rays which are generated outside the area of interest of the specimen to control the image contrast. Otherwise, the whole image will become blur and there will not be any information available for scanning point of view. These are some major manufacturers of scanning electron microscope. Phenom is one and big name. Now Phenom is under the umbrella of Thermo Fisher, and Phenom is manufacturing different type of SEM with different names. Phenom Ferros, this is tabletop SEM with a concept of field emission FEG source. Phenom Pro and Phenom Prox, this is all-in-one tabletop SEM, most popular model of Phenom. Phenom Axel, this is used for large or multiple samples. Phenom Pure, this is the entry level, or you can say the basic model of basic tabletop model of SEM, which is launched by Phenom. Then Geol, very big name in the field of SEM. Geol, you can say the inventor, or you can say the first model which was developed by Geol as well as this Cambridge instrument company. So Geol is very big name. Hitachi, new player although, but the share of Hitachi scanning electron microscope is increasing worldwide day by day. Joes is another established leader of in the field of SEM market. Tascan, very new player of Czech Republic in the field of SEM unit. If you will see the chronicle development of SEM, then you will find the first invention was made by Ernst Ruska in 1931. Ernst Ruska was a German physicist. He worked together with electrical engineer M. Knoll, and then both they presented the prototype of SEM, successful prototype of SEM in 1935. Although the resolution, maximum resolution of that SEM was 400, but that was the basic model. For that concept, Ernst Ruska got the Nobel Prize of 1931. After that, M. von Andem, they presented the concept of STEM with electromagnetic lens concept. In 1942, V. A. Zircon, they presented the concept of bulk sample scanning. Smith presented the electron signal processing and stereometer concept, and Ernst and Thornley in 1960 they presented the concept of grid-based detector. By after this invention, the application of SEM that has been enhanced drastically. In 1966, Cambridge Instrument Company of UK along with the Geol of Japan both presented the first commercial model of scanning electron microscope. In 2003, Goldstein they presented that scattered electrons can be converted into the form of light. In 2005 and 2007, Wonger and his co-worker they presented the concept of stereo scan, and at present the scanning electron microscope market is very rich in concept as well as various facilities. Various type of scanning electron microscope are present in the market. These are the application areas: thickness, surface morphology, appearance, size distribution, shape, dispersion, particle distribution, height, lateral dimension, cell size, size distribution. All these can be possible by means of a scanning electron microscope. So now I request to all scientific community to come together and help to the manufacturer to make India a self-sustainable country. Thank you very much.